Hey Wojciech, great to see you. Yeah, you're muted, so yeah, I can talk to myself actually. But
Hello.
great to yeah, great to see you. You're the last one for the whole event, but it doesn't mean anything. I mean, the order doesn't change anything. It was just the schedule. So I'm really glad that we have chance to see each other in a virtual person. I know you've presented a cool stuff for the end, and that's the pure value of such events. That even if you are entering at the beginning, in the middle, or just at the end, you get cool stuff from our speakers. So, Wojciech, just a short description about you, because I could say a lot. You're an experienced software engineer, and we all know about it. You're passionate about the cloud computing and software architecture. I know you are inspired also by a DevOps culture and cloud native approach. From what I had, you also share your knowledge during some lectures and workshops, which is pretty cool because it's all about sharing that knowledge, not only putting it under your table. And the session is called Serverless Application Pitfalls. I'm leaving you with the audience. Thank you once again for being with us, and the floor is yours.
Okay, first of all, thank you very much, Carol, for the introduction, and I'm very glad to be here with you and present this topic on this event. I think we can start. Okay, I'm not sure if the presentation is there already,
You're
but
good to go.
I hope so.
You're good to go.
Okay,
Yeah.
nice. Thank you very much. Thank you very much. Like the topic says, we'll talk about some pitfalls in serverless applications. I think some of the stuff will be basic for a lot of people in this event, but I think there is also worth to recap some things and put them on the table to just remember about them. So let's start. There was a long time since the serverless has been launched as a concept, and a lot of services has been launched under the serverless flag, let's say. But for many years, the serverless is more and more popular when it comes to some Google trends as a serverless as a concept, and about the concrete services from various cloud providers as well. So we can observe a continuous growth of popularity of serverless in many fields. And what's more, it's not only the popularity in the search engines, but according to the Datadog, Lambda functions in AWS environments are invoked 3.5 times more than 2 years ago, for example, and it's actually a huge growth in this field. And some might say that serverless is very popular in so-called small environments, some greenfield projects, because it has been some type of cool technology, but actually it is not anymore. It is used by the biggest and the broadest companies in our industry. So it is not really true anymore that Lambda is rarely used by enterprise and large environments. Last but not least, we also observe, and I'm sure you are aware of that, job descriptions and job vacancies for serverless developers and serverless architects and so on. So I think we could put forward a thesis that serverless architecture is just the future of the cloud computing and software development as itself. My name is Wojciech Dąbrowski. I work in Pattern Match as a solution architect. I have also a couple of AWS certificates. And besides that, I am one of the AWS community builders and one of the AWS user group leaders in the Poland. So it's nice to present this topic for you once again. A short disclaimer at the beginning of the presentation. Those things that I will talk in this presentation are just my opinions and are based on some experience building software for my clients and building software for product companies. Yeah, I'm very open to discuss all of those things, and don't hesitate to catch me up in the event or in some of other places. Just to recap, I'm sure you all, or maybe almost all of you, are aware of serverless trades, but let's recap them for a moment. Serverless as itself is a complete abstraction of the hosting infrastructure. So we are not aware of underlying infrastructure at all. We don't care about it even more than in the platform as a service model. What's more, we have pay-per-use pricing, so we are paying only for really used resources. We have simple and immediate provisioning and elastic scaling on demand. It is very nice stuff, very cool stuff when it comes to scaling to the high demand, but also scaling in to zero. And of course, high availability and redundancy is out of the box when it comes to serverless services. So you can say that it is really cool stuff. And when we think about it, we just can decide basing on those descriptions, those traits, that maybe we should make all of our services and all of our applications in serverless. And of course, I'm sure you all know that it is really low quality bait. So you can fall in one of the pitfalls that I will describe here. So let's think about all of those pitfalls. First of all, and actually, probably the most known issue with serverless is cold starts. And I will not dig very deeply in this problem because, once again, it is probably very well-known issue for all of you. But let's see what can we do with cold starts and answer the question if we should care about cold starts at all. So, long story short, cold start is a situation when the serverless component was not run for some period of time, and it has to be bootstrapped at the beginning. And this issue is the most visible in the applications, such as applications with user experience interaction. So let's say some type of client applications, when we have some type of user interface implemented as a mobile application or as a web application in the browser, and we have some backend application and probably some data store. And of course, we are saying about the implementation of backend application as a serverless. So it is very common architecture, very simple architecture. When we put the API gateway as a serverless load balancer at the front of our backend, and backend functions. Backend API is handled by Lambda functions. And of course, when it comes to the invocation of a single Lambda function, it will behave like that. So the first request will be cold started. So we'll have to wait some period of time to bootstrap our environment for a Lambda function. We will invoke we'll execute the code. And then the next request for the same Lambda function will be much faster because the container will be bootstrapped already and ready to serve just other requests. But when we will see the big picture of our environment and have some we will assume that a lot of users will use our application at the same time, we will observe a cold start in a very big scale, because it can happen that every of this user will just receive the increased time of processing event because of cold start. And what is the most frustrating for the user experience and users general is just a loading screen and some type of latency in using the website. What can we do with cold starts? It is very, very popular topic in when it comes to the articles in our industry, in cloud industry. It is very, very well known problem, and I will not focus on optimizing the cold starts for now. But what can we do when it comes to the to some native solutions provided by AWS? So first of all, we have a provisional concurrency feature, of course, for Lambda functions, and it is, of course, well-known solution for the problem. Long story short, we can set some number of instances that are always ready to serve our requests, and when we need some additional number of instances, it will scale out easily, of course, but it will not scale in below the number of setting in this case. And of course, in the result, we will observe that the response times will be much more predictable, and they will be much shorter in the as a whole thing. But there is one thing worth to mention here. According to the Datadog report, there are 75% Lambda functions that are over-allocated. So it means that the one of the cool and key features of serverless, so scaling to the zero, is just wasted and is not used at all. And clients are paying just for warm Lambda functions. So when we come back to serverless trades, we are losing two very important things. So we lose pay-per-use pricing because we have to pay upfront for some number of Lambda functions that are running every time, even when we don't have to have the ready instances. And what's more, we lose the scale to zero serverless trade. So it is also one of the drawbacks of this. And when we look on other services that can be used in this use case, I mean the API for serving HTTP requests, there is no much difference between Lambda used with provisioning concurrency and, for example, AWS Fargate. Because using AWS Fargate, also we need to provision and set up front some number of instances, and we can also easily scale up in any moment. So I would say that if the cold start is really problem for you, serverless is probably not for you for your use case. And when you are creating serverless application and are trying to optimize cold starts because there is a pain, with that, probably you should think about some other solution. The second thing that is very popular when it comes to the serverless is the limitations of resources. What I mean, of course, the limitations regarding the memory allocation and function timeout. We can only allocate 10 gigabytes of memory, and the Lambda function cannot last more than 15 minutes. And where it will be a pain, in the second very popular use case of serverless applications and serverless services, batch processing jobs. So when we have to run some process in the background of our system, it is very popular to implement it by serverless, because you don't have to pay for the usage when you are not using it, and when it is rarely used, it is very good cost saving. So let's say we have this type of process, so we have to run some backend logic in the schedule. Let's say it will be the process of getting the file from some FTP server or some other place, parse this file, call some external API to fetch additional data, and save the results in the database. So this is the big picture process. And of course, it can be implemented in the very easy way with Lambda function and CloudWatch events. But where is the problem? The problem is with processing time in this case, because along with the file size increasing, there will be increasing in the processing time probably. It's not true for every use case, but I have observed a number of situations in my future, in my past, that there was like that. And it is quite an optimistic way, because more likely it will look like this. So the processing time will increase much faster than file size. And of course, we will hit earlier or sooner. We will hit the limit of the Lambda function execution time. So what can we do with that? Refactor the architecture towards the parallelization. And what I mean is just to split the process to some multiple steps. So let's say we can perform the first step as downloading the file, and after that we can invoke, for example, the next Lambda function for processing a single item from this file, and invoke that multiple times for every item. So we will end up with multiple instances of processing single item Lambda, which will process the items asynchronously and in the parallel. And after that, of course, we have to fetch additional data and save results in the database. We can implement it like this and call the second Lambda from the first Lambda just from the API. I mean, from SDK. But we can also wrap up it in the process of step functions. It is also very helpful when we need to finish the process after processing all the items somehow. So when we need some type of finalization after the whole process, step functions will fit here very nice. But where you have a problem, maybe not a problem, but a big warning. A big warning is in this scaled moment when we are invoking multiple Lambda functions at once. So we have to be aware about our external resources that we are using. I mean, the external API and some database, which can be our database and be done in a serverless way, like DynamoDB, but it can be also some type of legacy database, or just some not really scalable database, like RDS, for example. So we have to be aware about this unlimited scaling. Of course, when we don't have the possibility of rewriting the solution to multi-step process, we can also use some other services to solve this particular business case. So we can use, for example, Amazon ECS to run this type of batch jobs, or use AWS batch to run more complicated and complex use cases. So when we have some long-running processes, we most likely we want to refactor this process to multi-step with parallelization when it comes to serverless usage. And I mentioned about the third issue, third pitfall. So the unlimited scaling. It is very cool stuff, but it is not so nice in every case in our systems. So let's say we have the following setup. So we have also some API gateway with Lambda integrations, and we are not integrating with some serverless data store like DynamoDB or S3, but we are integrating with Amazon RDS. It is very likely that we will at some point hit the problem with the RDS, because it is not so easily scalable in this basic version, of course, as Lambda functions. So we can of course use RDS proxy in this case, but it's also for RDS, and it's not applicable for every non-serverless component like external APIs or, for example, some legacy databases. We can also limit this at the API gateway level, but it is also not the case for every usage. And using non-serverless components, not only RDS, but non-serverless components at all in our serverless architecture is just the thing that we are making it very dangerous in our production workloads and very unpredictable. So what we should do instead of that? Well, use serverless components when it's possible. So it is, of course, it is the case for greenfield projects mostly, but still we should not use a lot of non-serverless components in our architecture. And if we are using non-serverless components in serverless architecture, we need to think about limitations of those not so easy scalable components. So we should avoid integrating serverless solutions with no serverless components. The next thing I would say is a lock-in, and a lot of you maybe we are thinking about vendor lock-in, but I'm not really thinking about vendor lock-in, but service lock-in. So not really avoiding the AWS lock-in, but avoiding serverless services lock-in. And I have no observation that when we are using serverless components, we are thinking less and less about our code architecture and software development best practices. This is my really, just basic observation from my experience. A lot of code in Lambda function is written not in the very good way when it comes to design patterns, when it comes to abstraction layers, when it comes to best practices, solid principles, and so on and so on. But I have no idea why is that. It is code like any other, and we have learned a lot from designing and from writing monolithic applications. So we can earn that and also benefit that in Lambda functions, for example. And one of the proposed architecture in software development, like clean architecture from Uncle Bob, or ports and adapters, or hexagonal architecture, on your architecture, should be applicable in the Lambda functions and serverless code as well. So we cannot forget about those principles in serverless development, and put those services integrations, put those implementation details in the correct place in our architecture. So the business logic as itself shouldn't be dependent on those services, and we shouldn't assume that we will use a Lambda function for this use case every time. So, in my opinion, the very, very important thing when it comes to the serverless development is a proper code architecture, so we can be prepared for infrastructure evolution. Because we can have the serverless API, for example, now, but in 2 years we can have the need to rewrite it to some type of, for example, ECS or Kubernetes. So wrapping it up, maybe we should not use serverless at all, because when there are some catch-ups and pitfalls, we should not use it in any case. You can see those voices everywhere. So serverless adoption of serverless is not working in every environment, and a lot of companies are complaining about it, because there were some expectations and they don't meet them. And it's a very, very good observation. And going back to this thesis from the beginning, that serverless architecture is the future of the cloud computing and software development, I would say that I don't agree with that at all. It is not the future of cloud computing and software development. It is just yet another tool in our architects and software developers toolbox. And we should use the serverless and serverless services wisely. So wrapping it up, basing on those previous observations, when we should use serverless, first of all, in some rarely and burst used APIs, but in small or medium scale. I didn't mention that, but at a very big scale and really big scale, serverless is just not really optimal, cost optimal. And the thing is, we should also use serverless in APIs only when we don't care about cold starts, because it is just one of the basic things in serverless that we will have the cold start. No matter how much we will optimize them, they will be present anyway. It's a topic maybe somehow connected to the previous presentation, actually, that building serverless is considered faster, and building some POC and MVP is very, very, very speed process, but it should be done with proper code architecture, which I mentioned before, because we need to be prepared for infrastructure evolution. But it is only faster when the development team is familiar with the serverless, because when you will give the new team and not very familiar with serverless the possibility of building serverless, I doubt it will be faster than building it traditional way. Also, other proper use case for serverless is batch processing, that is split into multiple small steps, and asynchronous and event-based processes. So serverless is very cool stuff for event-driven architectures, when we don't care about the response time as itself, but we care about the completeness of some process. There are some warnings about using serverless. So when you need stable and short response times, you probably serverless probably is not for you. Integrating serverless with applications with those no serverless components I mentioned before, as RDS, external APIs, and maybe some legacy databases, can be disappointing. We should consider the bottlenecks in our architecture as the whole, not only our components that we are writing for new projects. And what I mentioned before, serverless applications require some new skills and some type of mindset. And when you need to build serverless applications and you want to build serverless applications, it is wise to have some additional training or team augmentation in the future. And I have two takeaways for you after this presentation. Serverless, first of all, serverless is not a new silver bullet in IT industry and software development. We should not use it in every case and every business case. It is not the new way of building applications that will replace any other, and it is not for now and not in the future because of limitations that I mentioned before. It is just another tool for software architects and software developers to use it in proper use cases that I mentioned before. Here are some additional materials. The presentation is also available online. So the first link is for the whole presentation. My name was Wojciech Dąbrowski. You can reach me out in those places like email address or LinkedIn. And taking an occasion, I want to introduce and I want to invite you on the next AWS User Group Poland meetup that will be placed in November 17th. So thank you very much. And if you have any question, don't hesitate and ask them right now or reach me out.
Or whatever.
Or whatever, yeah.
No. Excellent. I mean, Wojciech, even it was the last session, you raised some really key topics. I mean, for the community. I mean, for people who are standing their first steps in the serverless, or even for those who are enough major to do next steps in terms of designing or improving their infrastructure. But I don't know whether we get any questions in the chat. But I'm watching your session, and I cannot stop thinking about asking you one thing. How do you think? What are the main misunderstandings that have an impact on the wrong designs in terms of the serverless? Because you raise some pitfalls, but how do you think people are start designing or even entering the serverless world and telling, okay, we would like to do the serverless part in our infrastructure? And how do you think, what kind of misunderstanding they experience?
Okay, I think those are the promises from marketing and sales.
As always, yeah.
But okay, it's cruel, but it's true. It's serverless as a concept, and serverless services are very good sold in our industry. So there are a lot of salesmen and serverless architects and cloud native architects which are really evangelists in the serverless, and it is fine because it provides more popularity to this concept and services, but it should be not used in every case. So it is not said in those sales materials and so on that it doesn't fit in all cases.
I know where's the point, and I mean I know where you moving that thread, and you're absolutely right. There has to be demarcation point between being an enthusiastic of a particular solution and being aware of the problems it might bring to a particular scenario. So, like with other technologies, so we can name even on-premise solutions uh, presented and glorified by speakers around the world, and it's not only tied to the serverless, but you're absolutely right that they want to do a great job, but from time to time they blur the reality, injecting the phrases or the namings in their presentations that it can solve whatever you want because it's a serverless, it's a niche actually, but still it's something new that can solve all your problems. And yeah, I think that's the point.
Yeah.
But
On the other hand, and you have mentioned about it also that it is not related to serverless stuff only, because it is related to some other technologies like Kubernetes, like Kafka, and so on. A lot of software engineers are using those components only because they want to use them. And it is also a problem in our industry that software engineers are treating those new toys as a new toys and not the key to solve some technical problem, but just to joy with them. And it is also one of the broad topic in our industry
yeah,
actually.
we could essentially we could spend hours on solving that particular problems because they've heard a cliche of a serverless. It's something which solves many problems. So okay, definitely it will solve something in our environment, and yeah, they're ending in a deep end because it hasn't solved their problem and open a box of new issues like you mentioned because they implemented before deciding where the pitfalls are, for example the ones you named and you presented. So Wojciech, once again, it was a pleasure to have you and that you joined the Serverless Days community because it's not only related to Poland, even the name is Warsaw, it's a worldwide community. So whenever people are willing to share their knowledge, it's a great pleasure to have such people like you among others. Once again, thank you for the effort, for everything. And if there are no questions on the chat, you can maybe, Wojciech, stay on the chat for a few minutes if any questions come up. But like I said, thank you very much.
Sure, thank you very much.
Take care.
See you.
See you then. Okay, so the second day is coming to the end. I would like to thank you from this point where I'm sitting. I would like to say thank you, huge thanks to all the speakers because you did the effort, and it's because of you we are here and we can present either pros or cons of the serverless approach. Like we had the discussion at the beginning with Alex about the changing the mindset. At the end, which was super cool because we could see two different angles of the security of the sorry not the security but the serverless itself, and at the end we could see some pitfalls and issues that might come up if you not choosing the technology deliberately and wisely. So guys, please remember that serverless is not for everything, and definitely that meetup is not to tell you that serverless for each of your problems you experience or encountered or whatever. So huge thanks to the speakers. I would like to say huge thank you to Monica and Tatiana from my team because you did a lot of preparations and spend a lot of time, even if it's the online version, but still you put a lot of effort. So I would like to say thank you, because without you, we couldn't organize this event. I would like to say huge thanks to our partners, Palo Alto, AWS. Hopefully next year, New will join the community and help us to prepare this meeting in person in Warsaw, and to invite you, all of you guys, to meet each other in reality rather than in online version, in virtually. And last but not least, I would like to say huge thanks to the StreamYard team. Joanna, you did a great job allowing us to focus on the tech side rather than thinking about the platform. Thank you, StreamYard, for having us and for taking care of us. And guys, that's all. That's the end. We will keep posting and updating you about the videos, the sessions we had. So you could, if you didn't manage to be with us today, still you will be able to watch your favorite sessions and your speakers. So I was your host this year. My name is Carl Junde. It was a pleasure, pure pleasure, to have you with us. Take care, guys. See you then next year.